So similarity, very important that we remember similarity is the three lines going down. What are we proving with similarity? We are proving the same shape. And that means that my corresponding angles are equal. And we also need to prove that the size is proportionate. And that means that the side lengths are in proportion. So I just reminded the other learners, the other groups, I'm going to remind you too what proportion means. So some notes on proportion. For something to be in proportion, it means there's a factor that exists between all sets of corresponding sides. It is the same factor that exists between all sets of corresponding sides. Let's just look at some examples of that. So if I gave you a side length of 3 and I told you that the factor was increased by 2, that means I am multiplying by 2, so my new line would be how long? If it was 3 and I multiply by 2, my new line, to be in proportion, would be 6. I could also go backwards and I could tell you that my new line is 18. The factor that got me there was 3. So what times 3 would give me 18? 6. Or I could alternatively go 18 divided by 3 gives me 6. And lastly, I could tell you what my initial line was. And I can tell you what my new line is, and you could potentially have to find what the factor is. What did I do 2 to get to 8? I multiplied by 4. So that is what I mean by proportionate, that there's some kind of a factor that exists that goes from one line to the new corresponding line. So now let's look at what this means in a triangle. Because that was just individual lines. We're not going to be doing individual lines. We will be doing a triangle. So I'm telling you that I have a factor of 5, that this line corresponds to this line, and that this line corresponds to this line. I've deliberately changed it up, and therefore the solid line corresponds to the solid line. So if I have a factor of 5, what would my lines going through it be equal to? My squiggly line, 3 times 5 is 15, and my solid line, 6 times 5, 13. So we had to make sure we knew which were the corresponding sides and that every side increased by the same factor. And that is what we mean by proportionate. The next note, just to recap, we're going to do the format of the proofs. And remember, there are 2 possible proofs for similarity. Even though you now know that we have to prove using angle, angle, angle in the test, we are going to write both. Just waiting for everyone to get up to the end of this page. So I split my page down the middle because I'm going to write them side by side. Anyone still busy? Okay. So I'm splitting it down the middle. I'm going to do the proof using angles and the proof using sides in proportion. Side by side. So format of proofs can be the main heading. My first one is going to be using angles to prove. And my second one will be using sides to prove. Okay, so I'm going to focus on the one, finish it, and then do the other, okay? So I need to know which triangles I'm dealing with, and I always start in triangle 3 letters and triangle 3 letters. I will be obviously given information on angles. So my statement would be about the first set of corresponding angles with its reason. My second statement would be about the second set of angles with its reason. Sorry, angles 2. And my third statement would be about the third set of angles and its reason. Therefore, I've proven that they are similar, and I've used angle, angle, angle. Once I know they are similar, I also now know that the sides will be in proportion. So I'm just going to say prop for proportion. Sides will be in proportion. So that is what a typical proof of using angle, angle, angle looks like. And according to our outline, that is what you will use in the test. And we will obviously practice it quite a few times. I'm just going to write here info about angles given. And if I'm using sides in proportion, well then I'm going to be given info about the sides. Anyone still busy with the angle, angle, angle one? Okay, moving on to the sides in proportion one. So I start the same way because it's still a proof. So in triangle and triangle. Now what's going to happen is that since I've been given sides, I need to prove that they have the same factor between them. So what I would do is I would find side 1 of the first triangle and divide it by side 1 of my second triangle and get an answer. Then I'm taking the next set, side 2, from triangle 1 and dividing it by triangle 2 and getting an answer. And then my third set of sides of the triangle, from triangle 1, dividing it from triangle 2 and getting an answer. And these answers need to be the same for it to be similar. I'll let you get that down first. And then I'll write the conclusion. Okay, moving up. Therefore, triangle 1 is similar to triangle 2, using the names obviously. The reason would be sides in proportion. And what can we conclude from that? That corresponding angles will be equal. So I'm going to give you a very, very, very basic one just to get those memories out of the archives from last year. And then we will gradually build it up. Anyone so busy? Our two triangles. So I want you to prove, or we are going to prove, that the following two triangles are similar. So I'm not going to give you the names because we need to practice that as well. So I am going to draw them. Are we given information about sides or about angles? Angles. So we are going to prove using angle, angle, angle. As per normal, I start in triangle. Now I actually need to name it. Obviously, I can't leave the three little lines. So my first triangle, I can choose whatever order I want. But the convention is alphabetical. But you could essentially do whatever order you wanted. So I'll stick to A, B, C. And triangle. Now the second triangle can't be any order. It has to match corresponding points with the first triangle. So if A is equal to 80, I need to use the one that is also 80 in my second triangle, which is my D. B is equal to 30, so I need to make my second letter E. And therefore the one that's remaining would be my last letter. They have to match. Once we're done with the proof, you'll remember why they have to match. So if you have forgotten, names must match. So what do I see? I see that A is equal to D, and it is given to me, so that's my reason. I can use one letter because there's no confusion as to how many angles are at A. There is only one, so I'm only going to use one letter. B is given to me, that is equal to E. And C must be equal to F, which is technically not given to me, so what reason would I use? Interior angles of a triangle, or we can call it that the third angle of the triangle has to be equal. But I would mark interior angles of a triangle as well. So now I've proven angle, 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 so I just need to conclude. Triangle ABC is similar to triangle DEF. We used angle, angle, angle. And just like my proof format that I wrote now, and I said therefore the sides are in proportion, I'm going to do that now. but I'm actually going to specify which sides. And this is why the names are important. Because it's AB and DE. First two letters from each triangle are in proportion. The second two from each triangle are in proportion. And the first and last from each triangle are in proportion. If you do not have the matching letters for the names, this will not work. And right now it's easy to see which are in proportion, but there might come a time where it's not easy to see. So it's better if your names are correct, because then there's no confusion. So if you don't believe me, you can check. AB, which is the 80-30 line, DE is the 80-30 line. 30 blank is the BC, 30 blank is the EF, and 80 blank is the AC, and 80 blank is the DF. So they are matching and corresponding. That means that this fraction once simplified equals this fraction once simplified is equal to this fraction once we have simplified. We'll also do an example. Even though we don't need it, we will write it in terms of making sure we have the same notes as the other class, of proving using sides in proportion. So that was example 1. We're going to do example 2 now. Anyone still busy? Okay, let's look at our second example. Looks like an arrowhead, 2 triangles. Sorry, I made the line too long there. So I'm going to tell you the names and give you some information. So I want to prove that triangle PQR is similar to triangle QSR. So I have given you the names. What information have I received? Sides or angles? Sides. So now I have to do sides in proportion. And the fact that I've been given the names actually makes my life easier, because I know that PQ is proportionate to QS. I know that QR is proportionate to SR. And I know that PR has to be proportionate to QR. So now I just need to go substitute the numbers. Please note, grade 9s, I did not look at the picture, I looked at the names to find the sides. Because if you look at the picture, I promise you're going to try and make QR divided by QR, which is not a corresponding side. I used the name of the triangles. So PQ is 10, QS is 5, QR is 3, SR is 1, 5. So you see how the 3 from the left triangle is actually corresponding to the 1, 5 from the right triangle. Just because they share the side does not make it a corresponding side. And lastly, PR is 6 and QR is 3. Let's go and simplify. 10 divided by 5 is 2. 3 divided by 1, 5 is 2. And 6 divided by 3 is 2. Therefore, triangle PQR is similar to triangle QSR, but my reason, will it be angle, angle, angle? No, it's going to be sides in proportion. Since I know that sides are in proportion, I also now know that I have angles that will be equal to each other. So just to list them, so on my picture I know that P corresponds to Q in the second triangle. So those two angles would be equal. Q in my first triangle corresponds to S in my second triangle. So those two would be equal. And R corresponds to R in both of them. So that would be equal. Yes. No. Side, side, side is a congruency reason, so you have to say sides in proportion. I know when Mr. Swanepoel did the video, he used side, side, side. That's why when I did the congruency ones, I said, do not do that. Because he comes from a private school where their sides are a little bit different. But if you had to do side, side, side for similarity, I would mark it wrong. So therefore, I can now say and write down that triangle, all these angles are equal, but grade 9s, there will be confusion if you only use one letter. For instance, if I refer to angle Q, am I referring to the dot, the cross, or the entire angle? So there is confusion. As soon as there's confusion, you must use 3 letters. So just to write which angles are equal, I would say QPR equals to SQR. So even though the P could have used one letter, that's fine, but the Q had to have 3 letters because there's confusion at that angle. Then my next one, PQR, is equal to the dot, and now I can use one letter because there's no confusion. So if you wanted to, that's acceptable, because S, there is only one angle that I can refer to. And lastly, there's confusion at this R, so I'm definitely using 3 letters. PRQ is equal to SRQ, or QSR, I mean QRS, SRQ. So as soon as there's confusion as to which angle, i.e. there's more than one option, you have to use 3 letters. If there's only one option, then one letter is fine. So that was just to get the brain refreshed. But as you saw on the outline, I am going to expect you to be able to prove similarity using angles and then finding the missing sides after the proof. So obviously we're going to recap that as well. Everyone ready to move on? Okay. So our third example, I guess. So I'm just going to write here so as per the paper 1 outline, because they tell you, you need to prove using angle, 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 and use it to find missing sides. So this example of how we do it will be what's expected in the test. Obviously the triangles that I give you in the test will be different to the triangles that I give you now, but the steps will be the same. So giving you 2 triangles, very basic proof. We will get more complicated proofs later in the week. Both your papers, as far as I know, are answered on the printed page. So you will not be writing on folio. So for instance, I'd give you the image just like I have now. My first question would be, prove triangle ABC similar to triangle DFE. So I've even given you the triangle names in the correct order. And now I would leave some space for you to do the proof. Just like everything else in mathematics, if it's got the same letter, it means that it is the same thing. So, for instance, in the first triangle, angle A is little a, and the second triangle, angle D, is little a, therefore they are equal. There's no confusion, so I would only have to use one letter. But I still need to start the right way, grade 9s. In triangle ABC, they gave me the name, and triangle, they gave me the name, DFE. A and A, so that's showing that they are equal. So A is equal to D, given to me on the page. B is equal to F, given to me. And lastly, C is equal to E. You can say third angle, or you can say given to me. Therefore, triangle ABC is similar to triangle DFE. Why are they similar? Well, we proved angle, angle, angle. Yes. Since we now know that they are similar, we also now know which sides have to be in proportion. And normally we would write it down, but you won't get the mark for writing it down because it comes into our next question. So I'm going to write it down. First to, second to, first and last. First to, second to, first and last. Showing which sides are in proportion and that those divisions are equal to each other. So my next question, so that was my question, my next question would say, find x and y. So hopefully you have the pictures drawn. So now it says find x and y. So I'm now going to move to using the fact that these sides are in proportion. So I'm going to recopy that in my question. And since I'm now making a statement about it being equal, I have to say why. Well, I know that they are similar. That is why. And all I need to do now is substitute in the lengths that are given to me. So AB is 15, DF is 3, BC is 30, FE is X, AC is Y, and DE is 4. And I don't think it'll be a problem with you guys, but just when we do start calculating, I'm going to make a note about cross multiplication, because that's what we're going to do, and learners try to cross multiply with normal fractions, which we can only cross multiply when there's an equal sign. Okay, moving on to the next part of this. So now I need to prove, or not prove, but find the actual value for x and find the actual value for y. What I do know is that all these fractions are equivalent. So once I divide them, they will give me the same answer. So I use that. But I'm not going to try and find x and y at the same time. I'm going to isolate one of them that's got the unknown value with the fraction that's got everything. So the fraction that's got everything is 15 over 3. And for the time being, I'm going to use 30 over x. So only choosing two, one with all the numbers, one with the variable. Now the quick and easy tip is to cross multiply. What we are actually doing is we're saying, well, we're dividing by 3 on this side. When I take it over, it's times 3. And I'm dividing on x on this side. When I take it over, it is times x. So essentially, the 3 gets multiplied across to the 30, and the x gets multiplied across to the 15. But if there's no equal sign between these fractions, so if there's a plus, a minus, a times, or a divide, you cannot do this. It is only if there's an equal sign. So very important, the equal sign between the fractions allows us to cross multiply. BTWN, between without the e's. So if plus, minus, times, or divide between fractions, you can't cross multiply. So learners very often get confused and they lose their marks. Because obviously the cross multiplication is easy, right? So they will always rather do the cross multiplication and they lose their marks. So for paper 1, if there's no equal sign, there's no cross multiply. You have to use the normal fraction rules. So 15 times x is 15x. 3 times 30 is
19.
But I don't want 15x. I want x to be single, positive, and by itself. So my next step is to divide both sides by what? 90 divided by 15 is equal to? There we go.
Oh, I guess that. Wow.
So you could have simplified your fraction on the left to make it 5 over 1. That would have been acceptable, but you don't have to.
Just a reminder to staff to please bring your RCL votes down to the box in the staff room at break, and prefix with contracts or reply slips, so please bring them to the office at break. Also just a reminder that auditions for the Joseph and the Amazing Technicolor Dreamcoat will take place tomorrow upstairs D Wing.
When did that happen? Did they announce that yesterday? About Joseph and the Technicolor Dreamcoat?
No.
Okay, we will find why tomorrow, but apparently we have a production coming. Joseph and the Technicolor Dreamcoat. Auditions are apparently happening tomorrow, which I think is